Hello everyone. The title of the today's lecture is Representation of Irrational Numbers on the Real Number Line. So, to understand the lecture, we require some prior knowledge. That is, we should know first that what are irrational numbers, and second, some basic knowledge of the Pythagoras theorem. So, those who are watching this video directly, I suggest you to first refer to the videos of irrational number. So let's start the today's lecture. To understand how to represent the irrational numbers on the number line, first we should know what is a number line, and that also we have covered in the previous lectures. So here I have just sketched a number line, of course a real number line, and marked a point 0 on it. Now I want to represent an irrational number. To represent an irrational number on this number line, so let's take an irrational number. Suppose you want to represent root 2 on this number line. This is the first task that you want to do. After this, we'll try to represent root 3. Fine. So, if we recall now the Pythagoras theorem, let me sketch a triangle here quickly. Suppose this is a right angle triangle. This is the 90-degree angle, and let me sketch it properly. Yeah, now it's fine. Let me call it sides A, B, C. It's right angle at B, and if I call these sides X, Y, and Z respectively, then the Pythagoras theorem says that the hypotenuse square equal to the sum of the square of its base and perpendicular, that is x square plus y square. Fine. Now from here the side z is given by its square root, x square plus y square. Coming from this step to this step, I have just taken the square root on both the sides. Fine. Now this, in our case, what I want to represent a root 2 on the number line. What I want root 2. So I'm asking you that this expression should equal to root 2. This expression should equal to root 2. So what are the possible choices of x and y on the number line I have in order to represent root 2? So the problem reduces to finding this expression. How these two quantities will be equal? This one. So now the simplest case which I can do is, if I choose my x to be 1 and y to be 1, then this quantity becomes square root of 1 square plus 1 square, which is 1 plus 1 2, and which is square root of 2. So that's why I'll be taking my x and y to be 1 and 1 respectively. So now how I'm going to use the Pythagoras theorem in order to represent root 2 on the number line, try to understand it properly. So now this I suppose fix my 1, that is length, this from this 0 to 1, the length is 1. Now I am drawing a perpendicular, that is here some 90-degree angle, and again this length I have taken to be 1. Now if I join this one, this, then it again becomes a right angle triangle, and this value, the value of the hypotenuse from this equation, if you solve this, and it's of course root 2, we know. You can easily pause the video and try to solve it yourself. Base and perpendicular to be 1, then the hypotenuse will result into root 2. You can easily try to find it yourself. So now this value, this quantity which we get is square root of 2. Now what you have to do, take this length, square root of 2, this length, and now just try to use this much of length and use a kind of an arc here. It will going to point out somewhere here. So if I use it properly, then if you observe here, if you use a compass, it will land somewhere here. So this point now which you got on the real number line represents this quantity. If I call it P, then this P is my square root of 2. Fine? Now I can run this. Now we have achieved the first task. We have represented root 2. Now I'm interested in representing root 3. So I first ask you to pause the video and try to represent it yourself, taking the possible choices of x and y. Try to plot it yourself. Now let's try to understand how we're going to represent the number root 3 on the real number line. So if you observe here, now from here I can run this much. I know this is my reference point 0 here. From here to here, this length, now I know it's root 2, it's square root of 2 because this point we have fixed. If now again, using a similar approach, I take this height to be 1. Because what I am interested in right now, to reduce this quantity, I have to choose my x and y so that if this side becomes square root of 3. So what are the possible choice of x and y I can take? If I choose my x to be, this base to be square root of 2 and this y to be 1, you can interchange them. If that is x, that is y, that is not a problem. Fine. So just if you try to, like I asked you to again make a calculation, substitute x equals to square root of 2 and y equals to 1 here and try to observe if you are getting square root of 3 or not. Pause the video and try to find it yourself. You can easily solve it. It's like this, which is square root of, this will cancel, this is 2 plus 1, which is square root of 3. So now if I now try to understand this one, what it means basically, this is your root 2, this much of length, this is your 1. So again you got a triangle from here, the vertex is O. This one, if I give it a name, suppose say this is my, this point is P, O, P, Q, suppose this point is Q, then OQ, the length OQ shaded in the dotted blue is, this is square root of 3 using Pythagoras again. It will be square root of 3 taking x and y, these two respectively. So again, do the same task, do the same thing again. This point now here got is, this represents square root of 3. Fine. I give you a task now to plot square root of 5 on the number line yourself. So we conclude the today's video with this much, and in the coming video we'll be discussing the decimal representation of rational numbers, terminating and non-terminating decimal representations. They're very important, and there are some relevant links in the description, so find those links. Do like our video and also do share about our initiative among your friends. Do subscribe the channel. Thank you so much.